and start the recording. And what we're covering is polynomial functions. Now, we've talked about polynomial functions a little bit already in chapter 3 because quadratics are a polynomial function. Now, what we're talking about now is really, we'll talk about quadratics still, but we're talking about any polynomial function of degree greater than 2. So what we talked about in chapter 2 or 3 will be included, but we'll also be looking at polynomials where the degree is greater than 2. So a polynomial function, a polynomial is a monomial or sum of monomials, one term. Polynomial function is written in this form here. Now, a sub n of x to the n, this entire equation, I'll go on and just circle it. Actually, just use a highlighter. This here is just a general way to write any and all polynomial functions. The a sub n minus 1 is just any constant term. So we're just talking about a number. X to the n minus 1, well, we could just put in a number and just say 50. So we could say that this is x to the 50th. Well, this here would be x to the 49th and going down. It's just saying that it's decreasing by 1, and we have it in this form here. It's considered to be in standard form when the biggest exponent, the variable with the biggest exponent, is written first, and then decreasing by power. Now, here are 4 different types. Now, a constant function is just going to be a number. It will have a degree of 0 because it does not have a variable. It is just a number. So negative 14 would be a constant term. Linear is just a line, so it would be a degree of 1 because the biggest exponent, it's not written, but would be 1. So 5x minus 7 would be linear. Now, quadratics, we dealt with those in chapter 3, would have a degree of 2 because the biggest exponent is 2. A cubic would be a degree 3 because the biggest exponent is a 3. And the last one that we have is a quartic. Quartic would be degree 4 because the biggest exponent is a 4. And again, all of these here are written in standard form. We have x to the 4th, x to the 3rd, x squared, x in our constant term. The degrees will be decreasing from left to right. Any questions on this here? Okay. Standard form, the polynomial in order of decreasing degree from highest to lowest. And the leading coefficient is the number in front of the variable with the highest exponent. Leading coefficient will always be the number in front of the variable with the highest power or biggest exponent. Any questions on any of this so far? Okay. Now, the first thing is that we do need to be able to determine if it is a polynomial function. That's what we're going to look at first. Now, the easiest way to do this is really not so much to give a whole bunch of classifications for what it is. It's kind of easier to classify by what it is not. First thing that we're going to say is that exponents aren't negative. A polynomial function will not have negative exponents. So if an exponent is negative, it would not be considered a polynomial function. And the second one is that exponents cannot be fractions. So we can't have x to the 1/3. Let's put it. So a negative exponent would be like x to the negative 1. We can't have that. Fractional exponents would be x to the 2/3. We can't have a fraction in the exponent. The next thing is that we cannot have variables inside a radical. So it really doesn't matter the power, but we can't have like the square root of x. Now they might be tricky, I don't think they will do this, but if they put the square root of x, say, squared, well, what is the square root of x squared? X. So that's not really a case. It's really if we can't reduce the radical, the variable's still stuck inside like this here, so the cubed root of x squared or the square root of x would not be considered a polynomial function. That would be a radical function. We got two more. Variables are not multiplied together. We cannot have variables multiplied together. Well, an example of this here would be, well, x times y. And the last one, variables cannot be in the bottom of a fraction. So as long as we don't have any of these here, then we can say that it is a polynomial function. Any questions on this so far? Okay. If we're good with that, let's look at our first actual set of examples. So these next set here, decide whether each function is a polynomial function. If so, write it in standard form, state its degree, type, and leading coefficient. So we look at A. Can we say that negative 2x to the third plus 5x plus 8 is a polynomial function? Yes. Because when we look through any of this here, do we have any negative exponents? Do we have any exponents that are fractional? No. Do we have any radicals at all? Do we have any square roots? No. We don't have any radicals. Do we have variables being multiplied together? No. And do we have any variables in the bottom of a fraction? No. So this here is, so this would be a polynomial function. If so, write in standard form. Is this in standard form? Yeah, so it's already in standard form. We don't have to change anything there. Now the degree would be 3, because when we talk about the degree, we're talking about the variable with the biggest exponent. Since the biggest exponent here is 3, the degree is 3. Now what would be our type? So it'd be a cubic, because when a function is a degree 3, it would be considered cubic. All of these would be considered polynomial, because we did say that it is polynomial. And the leading coefficient, because leading coefficient is going to be the number in front of the variable with the biggest exponent. Any questions on A before we look at B? So let's look at B. Can we say that this here is a polynomial function? So let's go through the checklist. Do we have any negative exponents? Are any of the exponents fractional? No. Are any variables inside the radical?
Actually, it stops right over 2, doesn't it?
It does. Because it's the square root of 2 times x to the fourth. So they tried to be a little bit tricky there. So we don't have any radical variables inside of a radical. Do we have any variables multiplied together? No. Do we have variables in the bottom of a fraction? So is this a polynomial function? Yes. Is it written in standard form? No. So we can say g of x is equal to, well, what needs to go first? Square root of 2x to the fourth. I'm going to rewrite it as x to the fourth times the square root of 2. We can reorder that. That's not bad. It's just a little awkward having the square root of 2 in front. Now, most would write the square root of 2 in front just to have it in proper notation, but we can have it as this way as well. Then we'd have minus 0.8x to the third minus 12. What would the degree of this function be? 4. What is its type? It is a quartic because it is degree 4. And the leading coefficient is the square root of 2. It's just going to be that number connected with the variable with the biggest exponent. Any other questions on A or B? Let's look at C. We have a negative exponent, so not a polynomial. I always forget that one, don't I? How about letter D? Yeah. Exponents are not negative. Exponents are not fractional variables inside of a radical. Variables multiplied together. Variables not in the bottom of a fraction. And really, this here, having a variable as an exponent doesn't work either. Because this actually would be considered an exponential function. It increases faster and faster as it goes up. Any questions on any of these here? Do we need to see another example of one of these? We feel comfortable with writing it in standard form, degree, leading coefficient, and type. Which one? So if we look at number 1, can we say that this is a polynomial function? Yes. We don't have any negative exponents. We don't have any fractional exponents. So really, I need to add in variables as an exponent. We do not have any radicals or variables multiplied together or fraction or variables in the bottom of a fraction. Now, is it in standard form? No, we need the 1.6, negative 1.6 times x squared to be in front. We need the biggest variable first. So we'd have negative 1.6 x squared first. And then what would be second? 5x, and then plus 7. We put it in standard form because now we do have the variables in order of decreasing power. The degree would be 2. Its type would be a quadratic. And the leading coefficient, negative 1.6. And that's it. Any questions on that one there? Now number 2 would be not a polynomial because we have x to the negative 2. Any other questions on these here? All right. Evaluating a polynomial function. We want to evaluate this function for the given value. So we want to evaluate it when x is equal to 3. Now, what it means when we evaluate, all we're going to do is take f of 3. So wherever there is an x, we're going to replace it with 3. So we'll have 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. Now at this point here, we could type this all into the calculator and it would do it for us. Let's see here. 88 or 98? Mm-hmm. Yeah, I just went on and worked it out by hand. You can type it all in and be just fine. Mm-hmm. Yeah, because 3 to the 4th is really just saying 3 to the 4th power times itself 4 times. Now, we could type this into the calculator because we can say 2 parentheses 3 close parentheses to the 4th minus 8 parentheses 3 close parentheses squared plus 5 parentheses 3 close parentheses minus 7 and enter, and we would get 98. Any questions on this here? There's another way that we could do this, same thing, is we can store a value in for x. Now, as I've said before, and we probably said in multiple classes, because the yellow calculators, the TI 30XS, do have a variable on there, but we tell you you don't need to be using it. Here, for most of these calculators that we're using, don't use the variable. It won't work out right because the variable has a specific value that we can define it as. So what we can say is 3 sto, S-T-O, x. 3 sto x. If we do this here and hit enter, what this is going to do is it's going to store 3 as the value of x. So whenever we type x in for this here, not when we graph it, it will say that it has a value of 3. So what we can say now is 2x to the 4th minus 8x squared plus 5x minus 7. Because I can type the function in with x, and if we hit enter, it tells us that it's 98. Now this here isn't too overly helpful because we could have just typed it in just fine the other way. But if it told us to, with this function here, 2x to the 4th minus 8x squared plus 5x minus 7, we want you to evaluate it for 3, -3, 4, and 7. Well, we'd have to type that in individually each time, yes? Well, if I want to do, say, -3 now, well, I can say -3 sto x. Yes? Because now it's stowed it as -3, yes? Now, I could go back and type it all in, but as we've seen previously, I can come up here and select the function, yes? And if I hit enter, it'll bring it back down. Did we change what the value of x was? Yeah, we said it's -3 now, so if I hit enter, so at -3, it's 68. Well, let's say if I wanted to find it at 4, so I can say 4 sto x, enter, so it tells us that it's 4. Come back up here, select it. So the store feature is nice if we want to type in multiple values and check for different values all at once. It also works well with negatives, because for our -3, we're not having to worry about making sure that I have the parentheses around the negative and the 3. It'll do it for us. Any questions on this here? Do we need to see another example with evaluating, or do we feel good with these here? Yes? In behavior is the last thing that we're looking at today. In behavior. Now, really what we're talking about with in behavior is how is the graph going to eventually behave in some way, shape, or form. When we looked at quadratics in chapter 3, all the quadratics were a U-shape, yes? Both ends where it'd end up going up or they'd both end up going down. Now, a quadratic, the biggest, or the degree is what? 2. It's an even degree, yes? Well, let's look at this here. Well, the bottom 2, if the degree is even, we see here eventually the 2 ends go both up or they both go down. And it actually works out for any polynomial function of an even degree. The ends will either go up or they'll both go down. Now, what happens in the middle will be different for each degree, for 2, 4, 6, 8, 10. But eventually, they're either both going to end up going up or they're both going to end up going down. And really to determine this, we need 2 things. We need the degree and leading coefficient. Because if we know what the degree and leading coefficient is, we will know how the function will behave eventually. And this can be helpful. Now we have 4 ways that this is going to work out. Either the degree is going to be odd, or it's going to be even. Now the leading coefficient is either going to be positive, or the leading coefficient is going to be negative. So the leading coefficient is just going to be the number in front of the variable with the biggest exponent. Now, if the degree is odd and the leading coefficient is positive, well, we'll say that f of x approaches infinity as x approaches positive infinity. And f of x approaches negative infinity as x approaches negative infinity. And really what this is saying for the first one. So f of x approaches positive infinity as x approaches positive infinity. As we plug bigger numbers into the function, bigger positive numbers, the function itself will get to be a big positive number. As we plug in negative numbers into the function itself will go to negative infinity. Now, when the leading coefficient is negative, well, x approaches negative infinity, x approaches positive infinity. That didn't change because we still have it for both. But the way it's approaching, because here, positive, positive, now it's going negative, positive. Here it's going positive, negative. It flips. So f of x approaches negative infinity as x approaches positive infinity. And f of x approaches positive infinity as x approaches negative infinity. Now for our even degree functions, they're going to go in the same direction both times. So f of x approaches positive infinity as x approaches positive infinity. And f of x approaches positive infinity as x approaches negative infinity. Because if it is even and positive, we're going up. It's going to open up. And if it's even and negative, the function is going to open down. So f of x approaches negative infinity as x approaches positive infinity. And f of x approaches negative infinity as x approaches negative infinity. And really, this will give us an idea of how the function is behaving, what kind of solutions we'll expect to see. Let's actually go on and look at an example to see how this works, because it's not as complicated as you might think. Describe the end behavior of this function. So when we look at this here, what is the degree? 4, which would be even. And what is the leading coefficient? So it's negative 0.5, which would be our negative, yes? So that's our leading coefficient and degree, because that's what we need to really determine the end behavior. So what do we have? We have even and negative, yes? So our even and negative tells me that f of x approaches infinity, negative infinity, as x approaches infinity, and f of x approaches negative infinity as x approaches negative infinity. Well, where did I get that from? From the chart, yes? And that's it. That's all we have to do. Because degree is even and negative, even degree negative. That's it. That's all we have to say for this here. Any questions on this here? So let's look at this one here. So what is the degree? 3, and that is odd. And our leading coefficient is negative 0.3, so the leading coefficient would be negative. So now I can look at my chart and see odd and negative. So it tells me f of x approaches negative infinity as x approaches infinity. And f of x approaches infinity as x approaches negative infinity. That's it. Questions on this here? Do we need to look at another example of this? Okay. Let's see here. Let me get... This here isn't in your note sheets, but I want to look at it with y'all, because I want to determine if we can determine the type of degree and the type of leading coefficient that we would have. So we do have a lot of stuff that's going on here in the middle, yes? But what are the ends doing? They're both going up, yes? So which one of these here has both of the ends going in the same direction. So the degree would be even. The leading coefficient would be. So this here, whatever the function is, would be even and positive. And we'll get into it later on, but it actually works out that the number of turning points that we have where it switches from increasing to decreasing is one less than the degree. So the least possible is one less than the degree. We have 1, 2, 3, 4, 5, 6, 7 turning points, yes? So the degree could possibly be 8, because it's going to be one less than it. So it would be 8. Okay. Because let's do a simple one here. Actually, let's go the other direction. This here looks like what kind of function? Quadratic. Well, the degree would be even, and the leading coefficient would be negative. Now, this could be a quadratic. It could also be a quartic. Because what we could have is maybe a little bit, let's see here, x minus 2. Well, this actually makes it a little bit easier. Because I'm just going to move this function over and say the peak's right there. Because this could be x to the 4th plus 4. This could be the function here. Or it could be x to the 6th. It could be any even degree because the end behavior does work that way. But what's in the middle might not always be the same. Let's look at one last one and then we'll be done for the day. What would this one here be? So we do have it going in opposite directions, yes? So the degree would have to be odd. Now, would the leading coefficient be positive or negative? It would be negative. Because as we approach negative infinity, it's going up. As we approach positive infinity, it's going down. Any questions on this here? Okay. Now this here does seem like it's something that's, why do we have this, or what's the purpose for this here? I'm going to just throw another graph up, but this will be the last one we'll look at today. Almost. Let's try one more time. So it comes down here. And this is the function that we see. Now we know that the degree is even, and the leading coefficient is positive. So we're told that it's even and positive. What do I know that this function has to do? Go in this direction. It's got to go back up, yes? Even though I don't see that it goes back up here, because it's even, I know that somewhere over here, it has to come back up, yes? And when we solved quadratics, we were looking for where the graph crossed what? The x-axis, yes? So that's telling me somewhere over in here, I should have another solution, yes? That's why this is helpful. Because when we start graphing these, oh, it's even and positive, I need to look somewhere over here for the other solution. Does that make sense? And that's why this can be helpful. But that is all we're doing today. So your homework is on page 172, problems 3 through 6, 9 through 14, 17 through 19, 21, and 22.